Students, now we are going to solve that exercise 2.2, question number 3, Roman 5, 6, 7, 8. In my last video, students, I explained up to question number 3, 1, 2, 3, 4. And now in this video, I will explain question number 3, Roman 5, 6, 7, 8. Then question number 4. Okay, student, now let's have a look how to solve this one. Students, now we are going to solve that exercise 2.2, question number 3, Roman 5. So I'm writing here that 3 Roman 5. Look here now, students. Question number 3, Roman 5. And the question is px equal to x square, and here x is given 0. So we have to solve this one, and we have to check whether 0 means x equal to 0 is the 0 of the polynomial px or not. Now let's have a look how to solve this one. Here x equal to 0, so we'll write here that therefore p0 equal to 0 squared. So 0 square will be 0 obviously, so we can say that p0 equal to 0. So we can say that therefore x equal to 0 is a 0 of x square. This is the 3 Roman 5. Now student, 3 Roman 6, and the question is px equal to lx plus m, and here the value of x is given. Now students, look here, value of x is given that x equal to minus m by l. This is the value is given here. So in the next part that we'll put the value here. So therefore px equal to lx plus m. Now in place of px I will just put the value here, implies p minus m by l equal to l into, in place of x we'll put the value of x only, then m. Now look, l and l cancel, so here it is minus m and plus m, so cancel these two, answer is 0. So students, it is clearly seen that px equal to 0, and if we put the value of x minus m by l, then p equal to 0. So we can say that therefore x equal to minus m by l is the 0 of px. This is the answer of 3 Roman 6. Now next one is 3 Roman 7. 3 Roman 7. Now look here student, how to solve this one, 3 Roman 7. So px equal to that 3x square minus 1. Now here value of x is given 2 times here. One is minus 1 by root 3 and other is 2 by root 3. These two values are given here in place of, these two values are given here. We have to check that whether these two values, whether the 0 of px or not. Now let's have a look how to solve this one. First one, I will put here that, look, therefore px equal to 3x square minus 1, and initially I will just put the first value, implies that p in place of x I will put here that 1 by root 3. So let me check here, 3 into minus 1 by root 3 whole square minus 1. Now look here student, after that 3 minus square is plus, and here nothing means into I have given here. Okay, now look, minus square is plus, 1 by root 3 square is 3 only, and there is minus 1, so cancel these two, so remaining part 1 minus 1, and this is 0. So if we put the value here that minus root 3, we'll get 0. So we can say that therefore px equal to 0. Now look student, after that, so we can write here that therefore x equal to minus 1 by root 3 is the 0 of px, the first one. Now look student, second one. Now student, next one, that px equal to 3x square minus 1, and here for the second case we'll write the value, implies p that there is the value is 2 by root 3. Now here is 3 into 2 by root 3 whole square, then minus 1. Now look student, after that here 3 into, there is nothing means into, now 2 square is 4, and there is root 3 square is 3 only, and there is 1. Now look student, after that if I cancel 3 and 3, then 4 minus 1 equal to 3. which means student we can say that therefore px is not equal to 0. Since px equal to 3 we have got here, so px not equal to 0. Therefore in the last line we write that here that x equal to 2 by root 3 is not the 0, it not the 0 of px. This is the answer of the question 3 Roman 7. Now next one student, 3 Roman 8. So we'll write here that 3 Roman 8. 3 Roman 8. Now look the question student, how to solve this one. Here px equal to 2x plus 1, where value of x equal to half. Now let's have a look how to solve this one. Here I will write that implies p, in place of x I will put here half. Now look here that 2, and in place of x I'll put here half, then 1. Now look, 2 and 2 cancel, since these are into, so we can cancel this. 1 plus 1 is 2. Now if 1 plus 1 is 2, then therefore we can say that px is not equal to 0. If it is not equal to 0, then we can say that therefore x equal to half is not the 0, is not the 0 of px. So it is clear to student in question number 3, if the value of px is 0, which means the given value is 0 of the polynomial. Now student, look, we are going to solve the question number 4. Find the zeros of polynomial in each of the following cases. There are total 7 questions and we are going to solve these 7 questions here one by one. Now starting from Roman 1, let's have a look how to solve this one. Now student, look here that 4 Roman 1, and here it is given px equal to x plus 5. So we have to find out the zeros of the polynomial. So basically in the answer I will write here that for zeros of px, therefore px equal to 0. Now what is the value of px here? X plus 5 equal to 0. So value of x, if you want to find out, then x equal to minus 5. This is the answer of the 4 Roman 1. Now student, look here that 4 Roman 2 is very easy actually. Px equal to x minus 5. Now same way, I am just pulling the line here, same way for zeros of px, and therefore px equal to 0. So in place of px I will write here 5x equal to 5x minus, sorry, x minus 5 equal to 0. So x is equal to 5. This is the answer of the x, which means this is the 0 of the polynomial. Now student, look here that 4 Roman 3 here. Now 4 Roman 3 is, look here now, 4 Roman 3 that px is equal to twice x plus 5. Now we have to write here for zeros of px, therefore px equal to 0. Now next one, twice x plus 5 equal to 0. Now twice x equal to, take 5 on that side, it becomes minus 5, and x equal to minus 5 by 2. This is the answer of the question 4 Roman 3. Next one student, 4 Roman 4 here. We'll pull the line here again. Now 4 Roman 4. In the question it is given px equal to 3x minus 2. Now look here, for zeros of px, therefore px equal to 0. Now look after that, here value of px is 3x minus 2 equal to 0. Now next would be 3x equal to 2, then x equal to be 2 by 3. This is the answer of the 0 of the polynomial. Now student, look here that 4 Roman 5. Now look here that 4 Roman 5. Okay, now here px equal to 3x. Now look here, we have to solve here that now for zeros of px, therefore px equal to 0. Now just after that, here 3x equal to 0, so x equal to 0 by 3. So answer is x equal to 0 only. Very easy. Now look student, after that Going to solve that 4 Roman 5, Roman 5 is done already. Now Roman 6, I will just pull one line here, then 4 Roman 6. Now 4 Roman 6, how to solve this one? The question is actually px equal to ax, and the condition is given a is not equal to 0, and we have to find the zeros here. So for zeros of px, for zeros of px, therefore px equal to 0. Now value of px is ax equal to 0. Now in the next step, x equal to 0 by a, so x equal to 0, 0 by a means it has some value. Since the question is in the condition is given a is not equal to 0, which means value of a has some value, so x equal to 0. This is the answer of 4 Roman 6. Now student, look the next one, that 4 Roman 7, and this is the last question of question exercise 2.2. 4 Roman 7, it is px equal to cx plus d, and here c is not equal to 0, and c and d are real numbers. Now look student, real numbers indicate that C and D, maybe it is rational and irrational. Why? Because real number consists both rational and irrational. So in this question we have to find out the value of x here. It's very easy actually. Now let's have a look how to solve this one. First of all, we'll write here that zeros for zeros of px, therefore px equal to 0. Now px equal to 0 means cx plus d equal to 0. Now next would be cx equal to minus d, and then next x equal to minus d by c. This is the value of the x.